Okay, it could be possible that some of you are maybe not starting out how you would like, but some of you are maybe sitting in different seats that you normally wouldn't have found yourself in, maybe as early as a year ago. But just for my own knowledge, did when we started class, probably better part of 3 or 4 days in a row, what might be the first thing we asked every day? Repeat that? No, no, no. What did we say about cells? We asked what maybe? What do they all what do they all have in common? So I didn't even finish the question. You knew what it was. So now whether do we have bad days? Well, everyone's going to have a bad day. Is it going to be every 3, 4, 5 days in a row? Well, we hope not. But and I know I get it. We're busy, but that's one of the aspects that gives you opportunity to go back and maybe look at this information. Maybe it's boring. Yeah, I get that too. But the race is long, okay? You've got plenty of opportunities. Just take advantage of them. And for bonus questions, maybe not everyone did them. Yeah, I know, I get it. You forget, and that's possible. But it's a new week, it's a new chapter. It's an opportunity to make up some ground. And, maybe one way to look at it is it true you ladies, for your volleyball matches, the last 2 times you lost the first game in the set or the match, right? Then did what with the next 3? You won the next 3. Okay. And I don't know if you want to call that a pep talk, but that's hopefully the best that we can do. But at least that I know, because I know so very little about volleyball. But that is something that has stuck out in my mind, is because I've noticed you've lost the first game, but then won the next 3. And it's easy to get down on yourselves. Please don't do that. Just keep plugging away. And with that, we gone tomorrow as well. And I don't know, there's another option as far as where to send you. We can't say let's send half here and half there. I talked to Mr. Hammer, and perhaps we'll send you across the hall to Ms. Button's room. We'll let you know that information tomorrow. Okay? And hopefully last week maybe it was overwhelming. And there's a volleyball match the night before. I don't know. There's many factors that may go into that. And so please don't get down on yourselves. All right. So has everyone seen online what their scores were? Do we want to see these or no? We do. Okay. Fair enough. Yes, please return. that everybody then? Okay. So please take a look at them. Even because I want to say there may have been a couple of mistakes in the addition. So please make sure 2 points apiece. Make sure the math adds up when you subtract the two. Yes. Same vocab. Yes. Okay, I would like these back, please. Correct. Okay. Thank you. Yes. Okay. Is this everybody? Okay. No, no mistakes on here. Okay. I don't know. I'll go back through these. I thought there might have been two. I just didn't have time to go back through them again. Okay. At least not before this class period. All right. Okay. Please just take one and pass it around. We don't spend a whole lot of time here in chapter 5. So probably the next few days, we're probably going to do something very similar when we start the day, just like last week. We would have said, oh, what do all cells have in common? And a lot of you would say, yes, they have a nucleus, they've got a cytoplasm, and they've got a cell membrane. Okay? That's why we continually ask those questions on a daily basis, and we'll probably do something very similar with this chapter. What are the movements across a cell membrane? And as you can see, again, we don't spend a whole lot of time on this. It deals with a concept called diffusion, and it's not going to be the only time you'll see that concept in this curriculum. I mean, as far as going through in general chemistry, we talk about that with gases. We talk about it with that of respiration in zoology in the animal kingdom, and organic, probably not so much. But anatomy and physiology, yes, we do that as well. Okay, yes, take one and pass it around. Yes, please. Is that everybody? Okay. Oh. So when you look at any of these terms, if you had to define one of them, or does maybe one stand out that actually requires energy, which one might that be? And it might even say that on there for you. Active transport does require energy. Okay? The rest, the other three are known as passive transports. Okay? The reason for that is they don't require any energy. Okay? The best example for diffusion is that of blood gases. Okay? So as you breathe in, okay, air moves in through your trachea, down in through your bronchi, your bronchus, into your bronchioles, and then to your really small structures that are known as your alveoli. That's where the capillary exchange takes place. Oxygen and carbon dioxide, really small molecules of gases, can diffuse into the bloodstream and out of the bloodstream. So diffusion is the simplest because it deals with the smallest materials, that being blood gases. Okay? And the best way to do this, think of the spring of the year, maybe some of you are already looking forward to track. That might be for a couple of reasons. One, you're outside. Well, you are with football as well. But then you know it isn't too much longer, and you're out of school for the summer. It's probably the biggest reason, right? Okay. Are we ready to make them adult decisions? Because some of you are possibly only 2 years away from that. Okay. And hopefully we're doing the best we can to get you ready for that. At least that's obviously our goal, to make you lifelong learners. I think that's the best way to put that. Okay. So as we said earlier, the best example would be that of blood gases. Okay. So what happens is only a set amount can diffuse through the brain until equilibrium is made. Okay? And you might be thinking, well, there's a lot of complex physiology that would go into that, but as you sit here, okay, you're inhaling your oxygen, you're exhaling your carbon dioxide, but do you think you are exhaling a large amount of carbon dioxide? I mean, do you think you're breathing in and all the available oxygen we soak in, and then everything we exhale is going to be the opposite amount of carbon dioxide? No, that is correct. And one of the ways or reasons we know that, okay, is, do we have any lifeguards in here? If you want to be certified as a lifeguard, you have to pass this test probably. Become certified CPR. Okay? Although a lot of the ways that CPR is taught and possibly administered have changed a lot over the years. When it comes to, for those of you who do take anatomy and physiology, one of the things we talk about right away in the first part of the year is the digestive system. And we incorporate an episode of MASH, as maybe your parents have watched that show. But it deals with a soldier who has problems that comes in and he hasn't eaten in possibly 2 weeks. Now, there's psychological reasons on why he has not done that, but they're trying to establish, well, what problem does he have? And first thing that might jump into your mind is, well, of course, it's malnutrition. He's just not eating. Well, here we are in 2018, and of course, when the show was being filmed, it was in the 1970s. But when did the Korean War actually take place? That's what MASH deals with. Yeah, in the 50s. I believe in sometime in 1950 to late 1951 or possibly 52 was when the Korean War had taken place. So in that amount of time, we just look at it as, that's old news. That's common knowledge. That someone's not eating, that's malnutrition. back in the 1950s, that's something that was just being diagnosed at that time. Okay, so the the point I'm trying to make is things in the way we understand and implement, whether it's technology or procedures, is always ongoing in the science and medical field. So when we're talking about CPR, no longer do you really do, you're going to do your chest compressions, but it used to be you were taught, you, I don't know if you were, but when we were, you do your 20 chest compressions, then what? 2 breaths. But now this has a common name. What do we call that CPR? Hands, maybe? Say that again. Yeah, well, hands on, hands only CPR, which means you are not giving them a breath. But when this was being taught during your parents' time frame, you might be thinking, well, if you're giving someone, you're exhaling into their mouth, you're not giving them pure carbon dioxide, because you had already established that by answering the question and saying, we don't exhale pure carbon dioxide. We only take in a set amount. Depends what your body is demanding at that time. Right now, you're not exhaling much carbon dioxide at all. Now, in, let's say, 40 minutes from now, it might be different for you student athletes. Now, how much you circulate around the gym for warm-ups, it's not much, is it? Because it's easier now, right? The first time you're going around, oh, geez, I'm out of shape. Did that ever enter your mind at all? Maybe a little bit. Same thing with football. The first few practices, oh, geez, I'm out of shape. But you'll notice a couple things. One, you're probably getting stronger. Two, your body is adapting to the changes that it's going through as far as the energy demands that are placed upon it. So this is always going to change, this concentration gradient, okay, depending upon what your exercise is demanding on yourself at that time. So if you're exercising a lot, of course, you're going to exhale a lot more carbon dioxide. And that's for a couple reasons. Your cells are metabolizing more and more energy, so carbon dioxide is going to be given off in a higher demand. And you're taking in more oxygen, because it's going to tie into a process that we call cellular respiration, where when your muscles get really, really sore, that's because they don't have enough oxygen, okay? And an example that we like to do in, some people do it, a lot of people, I'm not going to do that. And what that entails is just a very simple exercise where you just hold your arms out here like this, just like a T. And it sounds really, really simple. But eventually, some people can do it probably 5 minutes, some people 10 minutes, some people probably even longer. Okay, it's what your body has adapted itself to. I can picture some of you maybe watching this true life story. It's called Men of Honor. Okay, and it's about Navy divers. Okay, that go to do repairs on ships or submarine. I don't know if it's submarines, but on ships, so they have to be submersed underwater for a long, long time. So right now, maybe just sitting at rest, you might be able to hold your breath for, what would you think, 45 seconds? I don't know. I'm just throwing out a number. 40. You don't need to try it, but should you be one of those candidates for one of these different types of programs, if you're going to be an underwater Navy diver, you probably got to hold your breath for a long time. The reason we bring that up is you're probably not going to be very good at that at the beginning, but the further you get into that process, your body's going to adapt to that. You're going to be able to hold your breath for even longer and longer and longer. And we talk about that in anatomy and physiology a little bit when we get to the brain, because it goes back to, are we ready to make our own decisions for your own life? Some of you are thinking, yeah, I'm ready to be out on my own. Well, maybe yes, maybe no. But studies show that your brain, your frontal cortex has not developed fully yet. Okay? When the brain develops in its stages, it starts down here at the brainstem in the basement, then it moves its way up, and eventually your cerebellum develops fully, and finally, last is your cortex, especially your frontal cortex. That is where a lot of your decisions are being made, and what that does is it hopefully silences what we call the panic, well, not panic mode, but panic alarm, if you want to call it that. I don't know why, but I can maybe picture your mom out at Rapid City doing, working with OCS trainees, Officer Commission School. I don't know if that's ever happened before. Well, we're going to say she has, okay? So the reason I bring that up is part of the testing for that. Just picture your gear that you have on, your boots, your uniform, and then, because I went there for a weekend, I thought I was going to become an officer. I of course am out now. But one of the aspects that you had to do, and I'm not a swimmer. I just don't swim in the summertime, don't really know how to swim. So one of the things you had to do as part of this training was be pushed into the water, and if you want to call it a weapon or a rifle that was tied to a rope was thrown into the deep end of the pool, and you had to, I can't remember, you had to do something, grab the weapon, and climb out of the water. So the reason I say that is there might be nothing worse than not being able to breathe. And maybe some of you have older siblings, or maybe you do it to them, and maybe you get them into a wrestling headlock or something, or you smother them with a blanket or a pillow, and they're screaming and stop it. What are you nodding your head for? Oh, well, regardless, there's probably nothing worse than that. So what's happening is at the base of your brain, is again, your frontal cortex probably has not developed yet. In your brainstem, it's sending out a panic signal that we can't breathe. But once you get better at decision making, your frontal cortex finally catches up and it says, okay, let's logically think about this on what we need to do. Okay? Again, a lot of you perhaps have not developed that, I want to say, ability as of yet. Yes? Well, probably just through the course of growing up, we have people making them decisions for us all the time. Because really, you people probably aren't capable of making them decisions on your own until maybe what you think is maybe 9, 10 years of age, thinking, well, I know how to do this. Sometimes you might find yourself getting into a little bit of trouble. I mean, I guess I don't know how to do this. That's the only answer I can come up with. That is, you're not exercising your brain enough to have to make those decisions. Some people develop that quicker than others, because you can look across the room, and we're not looking at anybody. You might be thinking, that person is still so immature yet. So some of you are maybe smiling or chuckling or laughing, and maybe some of you are thinking, they're all thinking of me. And we're not looking at anybody, so that's only something that you can answer. So diffusion is again, the first type. We will continue on. We'll have this prepared for you tomorrow, or I'll let Mr. Deitch or Ms. Button know what it is to either look at the Science Channel and continue on with this, or maybe we'll just say work on your vocab. I will let you know tomorrow. continue at another time.